Typical class structure. Construction. Where we have skin. So this is skin. And we have stringer or stiffener. We can say this is maybe stringer or so here we have L angle, and we have for L angle the vertical section we say vertical flange, and horizontal section is horizontal flange. So for any angle, normally we call those section here is flange. So flanges. If we have T angle, also similar. So all the section we call it flange. If we have T angle, we have T. So this is flange, this is flange, this is flange. So call those are flange. So we have damage the flange. We have damage the flange. Any damage to be removed because the damage may grow. Any damage to be removed. Damage could be like crack, erosion, so for the you need to cut them off. Cut the damage section to prevent further growth. We don't want the damage to grow. We want to totally remove the damage. We cut them off. As we cut them off, we have problem because we lost area. Initially, we have this area. L. And then we remove this area. We cut it off. So this one we cut off. So we lost area. The one that you cut, you lost. You lost this. So you only have remaining area. So you only have this area. So if the area, say the area, I just put quick number, area, for the cross section of L angle is 100 meter square. Sorry, millimeter square. Now when you cut part of it, take out one of the flange off. The area now we lost half. 50 millimeter square. That's what you have left. And if the load that go through, if the load that go through here, say the load here, sorry, normally the section will be under tension. You pull this section and the load say 100 Newton. So it will be 100 Newton from both sides to be equilibrium. The section experience 100 Newton load. So the stress, okay, the stress sigma force or load over cross section area. So initially it has 100 over 100 millimeter square. You have 1. Okay, unit of 1. 1 Newton meter square. And then the second one, after you remove this section, the stress equation still the same, force over area. The remaining the load will not change, it will still be there. Newton over 50. Now you have what do you get? What is the new after you remove?
2. 2, sir.
Huh?
2,
Yeah?
sir. 2.
2. So we have 2. Right. 2 Newton millimeter square. What can you see? What can you see? This load remain constant. The cross-sectional area reduced. You can see the stress is going up. What does it mean? What does it mean when you have removed this section? The stress around this area is increased. What can happen when the stress is increased? Okay. What can happen when stress is increased? Let's go back, look at 2 graphs that I have shown you. One is the graph stress strain. One of the graph is stress cycle. So stress and strain, you can see we have plot until it's failed here. So here is the failure, FTU, failure stress ultimate. And also we have yield point somewhere. This one is FTY, yield. Yield means start to. After the yield point, if you release the load, the structure will not come back to its original dimension. So we have permanent deformation. So as the stress go up, and if the stress go up very high, you may go up to the yield point, or even go up higher again, you may reach the FTU. If the stress reach the FTU, the structure will fail. So this is failure. And the structure will break. So that's why. That's why we want to control the stress. We do not want the stress to become too high until it causes the structure to break. Secondly, there is stress and cycle curve. We go back to mechanics of material, you learn about this. Who failing mechanics material, you may have problem to understand. So, stress and cycle curve, as you increase the stress, what you can see, the cycle will be less. It was here before, high lower stress, as a now we cycle. This is life. So what can happen here is you, when the higher stress reduces the structure. After this, I put one quiz on this. Okay. That's why we are trying to avoid not to, in doing the repair, you right to avoid high stresses.